Thanks, Luke. So this presentation is going to focus on one aspect of dust control. I'm not going to cover a wide range, it's just specifically focusing on dust control in mobile plant. There's a few messages I'd like you to take away from today. There's 4 on this page. The first one is cabin integrity. Don't take cabin integrity as a given, as an assumption. Check your cabin integrity and make sure that it works, and I'll talk to that as we go through. The second one is filtration. It's critical to ensure that the filtration in mobile plant cabins and fixed cabins like crusher control booths and that have the right capture efficiency to protect the worker from respirable dust, that very fine invisible respirable dust. Third takeaway is cabin cleaning methods. There's a lot of failure in control in terms of operators cleaning their cabins, and I'll talk to that, provide some information on that. And the fourth one is falling exposure standards. We've heard a little bit this morning about the review of exposure standards by Safe Work Australia, and as exposure standards fall, in particular the impending reduction to the silica exposure standard, it's going to become increasingly important to effectively control exposures in places like in cabins. So there's the 4 messages that I'll focus on today. Dust control and I'm mostly involved in mining and quarrying, but dust control is about preventing dust getting in the air. Respirable crystalline silica is only dangerous if it's in the air and if you breathe it in. If you can prevent one or both of those things happening, your worker is protected. Primary control measure obviously is eliminating the dust. Don't let it get into the air. So that's your water suppression, treating the source to make sure that dust doesn't become disturbed or get in the air. Extraction systems, screen covers, shrouds, that type of thing on equipment. If dust does get in the air, the next step, I suppose, and I'm boiling this down to basics, the next step is interrupt the pathway between the source and the worker. Right? That's things like water sprays, so suppression sprays, a misting spray to try and knock dust out of the air. That's problematic. Once dust gets in the air, it's very difficult to actually drop it out of the air with a water spray. Or you can enclose your worker in an enclosed cabin. That's a form of separating them from the exposure. The third one is, if it gets in the air, if it gets to your worker, you protect them. But that's the last line. You don't want it to get to that point. But obviously, in a lot of circumstances, it will. But I'm only going to focus on this particular one, the enclosed cabins, today, and how to go about trying to ensure that that particular control is effective. Dust is ubiquitous in mining. As you can see from some of these photos, it's very difficult to separate an enclosed cabin from a dust source. If you've got dust, you're going to have workers in enclosed cabins with generally a lot of dust around them. This is why it's really critical to make sure that that control measure that your worker assumes is going to protect them is actually effective. In 2010, coal mines did a review of their dust self-assessment reports, and about 90% of mines and quarries rely to some extent and to a large extent on enclosed cabins to protect their workers. This is, many of these photos are ones I've taken myself in the last 12 months. This is a quarry. You can see there's mobile plant tracks around the end of this screening plant. There's an excavator up on the hill behind in its own little dust cloud. So those sorts of environments are the ones that make enclosed cabins critically important. Excavators, trucks, loaders, these two are a mattress rock processing area. There's an excavator and a loader there. So again, it's about making sure the cabins work. Enclosed cabins are a little bit like a gas detector. If you give a gas detector to a worker, a lot of workers, as long as they can see the light flashing, they assume that they're protected. I believe that because they've got a gas detector, it's going to stop them from being exposed to something. in a lot of cases, that's a very dangerous mistake to make, because they have to understand how it works and make sure that it's effective. Enclosed cabins are a little bit the same. You put a worker in an enclosed cabin, air-conditioned cabin, and they have an assumption that they're protected from dust, especially when they can't see it. But is the incoming air that's coming into the cabin through the air conditioning intake, is it effectively captured? Is the recirculating air effectively captured? Secondary exposures from clothing, opening and closing the door, drying material on the floor, being scruffed by feet. And how is the cabin cleaned? How regularly is it cleaned? Do they blow it out with compressed air? Do they sweep it out? Or is it cleaned at all? You can see here this particular picture is evidence of a pretty comprehensive failure of a whole range of control measures. Not only is it extremely untidy, but the seals on the door were busted, the air conditioning didn't work. Somebody worked in that pretty much for 10 hours a day and was quite happy to do that. It's a bit surprising the types of conditions that some workers are happy to put themselves in. Exposure potential. It's fairly important to identify what the exposure potential is for workers. So of the roughly 300 workers that I've put samplers on in the last 12 months, 20% of them self-report that they use compressed air to blow cabins out. That's 1 in 5. And that's probably much higher. These are just the guys that are willing to put their hand up and say that they do that. Another 36%, so we're talking better than 50% of all workers who operate in mobile cabins either blow out or sweep out, dry sweep out their cabins. And about 1 in 3, 30% roughly, either had no or inadequate training in silica or how to use a dust mask or respiratory protection. Many of the guys that I talk to about blowing out cabins, when you ask them, how do you stop yourself breathing the dust in, and this is not a joke, they say they just turn their head away and hold their breath. That's how they control their exposure. We saw earlier on, and I'll have a repeat of a slide that Peter Aspinall had up before. We'll see why that's not effective once we have a look at particle size and suspension, how long it stays suspended in the air. These are some examples of cabin air conditioning filtration and the ineffectiveness of some in-cabin filtration. So some of the pre-filters or the recirculation filters are just made of the kind of foam you dig out of the chair you're sitting on, which is entirely ineffective at trapping respirable dust. Filters difficult to access, deformed or damaged filters. This is a recirc filter in the frame. The plastic frame was cracked and busted. The filter wasn't sitting properly. All this contributes to a recirculation of dangerous particulate matter within the cabin. Overloading, again, difficult to access and maintain, and this one clearly hadn't been maintained for a while. This one's a filter in a mounting and just wasn't mounted correctly when it had been put back in. It's not sitting in the mounting frame, the bracket's in the wrong place. So you get a big gap there, and air's like water, it'll follow the path of least resistance, so your dusty air is going to track through that hole rather than try and work its way through that filter. Door seals in cabins, either damaged, missing or ineffective, especially with platforms that are where you've got the access platform right at the bottom of the door. You get material dropped on that, sits in the grate, and every time they close their door, they're smashing rocks in against the seal that damages it. Door on the right there is an enclosed, is a fixed cabin, and you can see from the scuff marks on the floor, that door took a fair bit of effort just to get it open and closed. So self-closing doors are valuable in these sort of circumstances where the operator doesn't leave it open. That's how it was when we arrived, it was partially open. But a lot of that had to do with the air conditioning system, which I'll show you in a second. Damaged door seals, dust, piles of dust clearly visible inside the control booth. And then, again, door seals on that control booth there. And often these little control booths are positioned right above the primary or above the jaw crusher so that they can see whether there's a blockage. So you'll have a little cabin with a busted door and this sort of air conditioning system right next to their primary dust source. And it's not surprising that some of the results I'm finding from static sampling are showing a particular problem with ingress of dust. But that's a system there with the pre-filter clogged up and the pre-filter removed with dust all over the condenser there. Clearly a lack of maintenance. This is another one. Again, the air conditioning system on initial inspection just looked like it wasn't working, but there was a huge wasp nest in the middle of this air conditioning system, so that, I don't know when the last time was maintenance looked at that. In summer in Queensland, the workers in these little cabins, and some of them are not much bigger than a telephone booth, are very reliant on the air conditioning to keep them, or to make sure that they don't open their door to let cold air or cooler air in once it starts to heat up. And maintenance of these systems often is very infrequent. Most or almost none of the mobile plant pre-start checklists that I look at consider air conditioning filtration or door seals. Many of the air conditioning filters only get looked at the scheduled service, and sometimes that's a 250-hour frequency, and a lot of dust can build up on a filter in 250 hours of work, especially if you're in a dusty environment. That's an example of your normal mobile plant pre-start checklist, and you can see there's a tick box for air conditioning, but that's just whether it works, whether it makes a noise when you turn it on. And the only other one that goes close to looking at the condition of the cabin or the door seals is this one down the bottom. The H is not a high, medium or low, that's Henry's initial. He puts H for Henry in there when he has a look at it. So you can see if an operator is looking, if we're going to get operators to look at something, we have to actually prompt them to look at it properly. And there should be more detail about what the worker's looking for. Exposure potential again. These are, I was talking before about dust ingress in the cabin, so one of the things that I'm doing when I go out and sample is if I've got a mobile plant operator or a crusher control room operator, I'll put a personal on them and then put a static in the cabin that he's working in, a static sampler. And there's quite a lot of value in static samples when you're looking at whether or not the environment the worker's in is actually controlled, especially given that you won't find any workers who wear dust masks or respiratory protection inside these cabins. So these are 4 examples of results that I've found comparing the statics to the personals. And this is roughly 20% of the statics I've taken as showing this sort of trend. First one's a crusher control booth. The static samples for both respirable dust and silica were higher than the operator's personal exposure. That meant that the times that he was stepping out of the booth into the crushing plant, he was reducing his exposure because he was outside of that room. And he spent his whole day inside that booth. That's one of the little dodgy ones above the crushing plant or the main jaw crusher. Crusher control room, the CCR is a room, this was a bigger one, but the static silica was better than 50% of the personal silica, so more than 50% of his silica exposure, again, was probably coming from being inside that room. Excavator, static dust was higher than his personal, and the silica was over 2/3 of the personal exposure. And loader cabin down the bottom. So it's fixed plant, mobile plant excavators, loaders, any hygiene technicians in the room. If you're going out into the field and you have the opportunity to put some statics out, I'd strongly suggest that you start looking at these locations to have a look and see whether the operators are actually exposed while they're in their booths, because there's some really interesting information starting to turn up about that. This is that Respatrol that Luke was talking about. It was a project that was done back in about 2010 by a couple of inspectors, Fritz Dukic and Kevin Hedges. Went to a sandstone plant and had a look at exposures of workers in the excavator with the cutting wheel, cutting sandstone blocks, and tried to have a look and see whether or not there was correlation between exposure in the cabin using our data logging instrument and what they were doing outside. And these 4 circled times when the operator was cutting blocks. So this is static sampling in a cabin, linked up with when the operator was actually cutting blocks or trenching outside. And there was a clear correlation between operation outside and what was happening inside. And it's just simply a fact of the OEMs, the original equipment manufacturers' filtration is not adequate to capture respirable dust. It'll sift out the big stuff outside, but it won't pick up that very fine respirable dust. Cabin cleaning. This is one of the, you saw from that photo earlier on, that particular cabin that was quite filthy. That's not uncommon to see, dirty cabins. And one of the potential secondary sources of exposure is when the operator cleans it. As I was saying before, 1 in 5 will blow it out with compressed air at the end of the day. And you might take a whole day of being in a cabin with relatively low exposure and negate all that by how you clean at the end of the day. There's some methods for cleaning, and obviously there's some that you would prefer over others, but it doesn't have to be just one, it can be a combination. But it may be quite important to have a look at how you clean and risk assess it. None of the instances that I've found of workers using compressed air had been risk assessed. When you took the SSC at the site, there was no assessment or evaluation of that process. It was just something that the guys had always done. This is the one I was talking about that Peter showed earlier on, and what I wanted to focus on here was the small end particle size. When you look at average size for respirable dust, the average particulate size is about 4.25, a little over 4 microns in size. Obviously the smaller dust is, the further it penetrates into your lung. And here we've got the very small particle size down the bottom end that can stay suspended, this is in still air, for days, literally days. And if you've got turbulence, they're going to stay suspended in the air. This slide's a preamble into the next series that I'm going to have a look at with regards to filtration. Focus on dust size, so 1/250th of a millimetre. That's dust you just literally won't see. So a worker will think that they're in clean air when they're actually not. Those exposure limits are important, especially the bottom 2. When you look at the potential reduction, well, the last one actually, respirable crystalline silica is probably going to go down to about 0.05. When you look at what that means in terms of industrial vacuums and filtration, a light hazard, and the standard for vacuums links the hazard and the efficiency of the vacuum into the exposure standard. Lights and mediums are 0.1 milligrams per cubic metre or less. So when silica drops, you'll need this H-class. Arguably, you could say because silica is a carcinogen, you should have a H-class now, not an M-class. But what the H-class is, down the bottom here, is a capture efficiency of 99.95%. That's what you're looking for in a filter or in an instrument for a high hazard. If you were to take this standard and apply it to the air conditioning filtration, HEPA filters for filtration, this is the Australian standard, that's about where you want to be, grade 3 or better. Anything less than that is questionable in terms of its ability to effectively capture respirable dust. And if you look at the European standard, which is what a lot of standard filters now are rated on, you'll hear people talking about HEPA H13, H14, whereas the Australian standard, their grades means the same thing. Your HEPA filter arguably should be H14 if you're going to meet that standard. H13 is in that just maybe not quite good enough. But that's going to be the tag that you're looking for on your vacuum cleaner. So if Your cleaning mobile plant with a HEPA vacuum cleaner, it's going to have this sort of rating, and not just for the filter, but for the instrument itself, for the machine. I've got a link in there. I don't know whether the slides are going to be provided, but Industrial Relations has a link for testing of H-class vacuum cleaners. It's a little bit difficult to get it up in this forum, but there is a link there if you want to have a look at it. This just gives you a little bit of an idea in coal of where our problem might be. So this is respirable dust exceedances over the exposure standard for respirable dust. All those circled occupations there, which works out at around about 30%, are operators who normally spend the bulk of their day in an enclosed cabin. So we're getting exceedances for dust, and we're getting exceedances for silica, for operators who should be protected. And this is going to increase when the exposure standard drops for silica. There's going to be more of these, and it will become more of an issue to make sure workers are protected. So filtration in cabins, the photo from earlier on was no cleaning, no filtration, no inspection, and your best case is a pre-cleaner with a HEPA filter, pressurised cabin, regular cleaning, regular maintenance, and worker awareness. Have a think about where your process is in there. Whereabouts do you sit? Do you do inspections? Do you look at your cabins? Do you clean? How do you clean? How good are you in terms of how you're protecting your workers during that process? There's a couple of organisations or providers that will retrofit good quality, will fit filtration systems to existing cabins, to plant. And both of them have what's called a pre-cleaner, and that's like your scrubber from earlier on. So pre-cleaner that just basically spins out the oversized material and stops your intake filtration from being clogged up as quickly as it would otherwise. So that's one type. This one you can see is a second type with a propeller at the top or a fan at the top that spins out the oversized dust. This type of equipment will extend the life of your filtration, your HVAC system, if you install it, but there is a cost for it. Here's a couple of slides just that talk about how to go about the fitting, pre-cleaner outside and filtration inside. Both of these manufacturers you'd be able to source on the internet. Catch up to where I am. So essentially some of the issues are filtration. Have a look at whether or not your filter is actually working, whether it's going to capture. Talk to your equipment supplier and find out whether or not the filtration, the intake, and also the recirculation filters are effective. Look at the management of dust brought into the cabin. How is dust treated when it's in the cabin? Is it recognised? Is it identified? And how is it cleaned? Maintenance of filters, maintenance of seals. If you do all these things, you will greatly reduce the exposure potential of your worker in the cabin. Education awareness is a really critical one. As Daniel was saying before, we're still getting people that turn up that have no idea what silica is, despite the black lung issues in the news, despite the stone bench tops. Workers won't control something if they don't know why it's important to control it. And it's really critical to get that education message out there. And one of the other issues is your cost to retrofit. But the cost, there's a benefit to that. And from talking to the suppliers, to retrofit a piece of mobile plant depends on the plant, depends on what kind of filters you want to put in and how extensive you want to go, but it can be between $5,000 and $9,000 to have somebody else retrofit it. And a lot of that is also involved with site time and completely sealing the cabin. So these guys often will go and close up any penetrations or holes in the cabin at the same time to give you that integrity. And it reduces the risk of exposure to your workers. So there are some benefits to paying for these things. Aspects to look at: do workers understand the risk? Are there signs of dust ingress in the cabin? So when you're on site, you can pick up whether or not there's an issue from doing a number of these things. Have a look at your cabins, have a look at your seals, have a look at your filters. What's your inspection process, both pre-start and maintenance? Is the cabin pressure tested or leak tested? Is there evidence of dust ingress or that kind of thing getting into the cabin? And personal exposure monitoring. It's quite important to do the exposure monitoring so that you can identify what level of control you need and whether or not your controls that you've got in place are actually working. So, just to summarise, don't take cabin integrity for granted. Have a look at your filtration and make sure that it's good enough to capture that dust. Look at your cleaning methods and identify whether or not that cleaning is actually contributing to the exposure and providing those secondary exposures, especially not just with air conditioning filters but engine air filters. Often they'll just get banged out in the side of the machine and there's another exposure there. And make sure your cleaning methods are appropriate. That's just an acknowledgement to a couple of those providers whose photos or pictures I've used. I'd also like to thank the good folks at Curra for some of the information on the standards, and happy to take questions. Excellent. Okay. Were there any questions?
How often do you see cabins like that?
Oh, half the sites I go to. Some are not that bad. I saw one last week that there were cobwebs in the cabin, but the air conditioning didn't work and the windows were broken. So, you know, and the spider was in good nick. That's quite common, especially at some little sites. But there are other places, other organisations that have really thorough cleaning processes. It really is very one end of the scale to the other. Yeah. No other questions? All right, that's you.
Yeah, that one easy.
Thanks, mate.